Hi, everyone. Welcome to today's webinar, Mastering Indoor Air Quality, Navigation Solutions for Containment Spaces. This presentation is brought to you by Omni Clean Air in partnership with the Pacific Northwest section of AIHA, and we're really glad to have you here. So some quick housekeeping first. There's a chat feature on the right-hand side of your screen. Please feel free to add in questions throughout the presentation, and we'll also have a Q&A at the end. And this event is being recorded. So following the event, we'll send a copy of the recording to all registrants. Our presenter today is Jeff Abramson. He has been a product developer for his entire career and is the head of product for Omni Clean Air. He graduated with a degree from the University of Michigan, and he'll be taking us through the educational session today. His contact information is listed on this slide below. And with that, I'm going to go ahead and hand the floor over to Jeff. Welcome, Jeff.
All right. Thank you, Jessica. I really appreciate it. Looking forward to connecting with folks on some topics here around indoor air quality. First, a little bit about our company. Jessica mentioned it, but Omni Clean Air, we've been around for 30 plus years. We have several brands, our Omni Tech brand, our Omni Clean brand, and our Agri Air brand. The common theme across all these brands is it's all about keeping professionals safe from pollutants and high stakes environments. We've been doing it for a long time, whether it's healthcare, whether it's construction, whether it's abatement, community spaces, not just healthcare, but other community spaces, corporate offices, classrooms, natural disaster responses. And then we also have this Agri Air line of product, which is about making sure that indoor crops are kept safe from organic pollutants. So a wide variety of products. This is not a product presentation. We're not going to talk about our products. It's not a solicitation, but just a little bit about us that helps connect the dots here. So we're talking about indoor air quality. This is a rhetorical question. Is indoor air pollution a real issue? Of course, it's a real issue. The data, more and more recently is helping to reinforce that. There's this World Health Organization citation here, 7 million people dying globally each year due to air pollution linked reasons. Lots of things changing in the world, viruses evolving, wildfires on the rise, climate change. The urgency here to address this problem just continues to rise. On top of that, employees are raising the stakes themselves. They're demanding, better working conditions. They're learning more about indoor air quality, and they're demanding that their employers address those in their workplaces. It's tricky because these standards are not yet fully in place. They're moving standards, they're confusing standards, and we'll talk a little bit about that. But for example, just recently, the World Health Organization just published a report, just literally in the last few weeks here, about their position on airborne disease transmissions. And people are reading that and responding to that. Last year, ASHRAE published a new standard, it's standard 241 on the control of infectious aerosols. And the World Health Organization, again, they've recently released this new online tool, the Airborne Risk Indoor Assessment, ARIA. All of these are, increased awareness around this problem. There's the ICRA standards, infection control risk assessments that are being used in health facilities. Just yesterday, for example, we learned about a big health set of centers here in Washington State that are just now deploying, this new version of the ICRA risk assessment. So moving standards, growing standards, higher awareness. It's not clear necessarily to all of you that are working in this environment. What do I do? How do I know? And we're going to try to help answer some of those questions today. Indoor air pollution can be quite a big problem. You can see this other quote from the EPA at the bottom of the slide here. So Before we move on and get into some of these details, we'd like to get a quick poll here from the attendees here. So I think Jessica will start this poll here.
Yeah, so the poll will be over on your right-hand side. And the question is, have you consulted or advised on indoor air quality solutions? Yes or no? Great, we see your answers coming in. Just a couple more seconds here. Okay.
Yeah, it was started off at 100% there, so I was worried that we could just end the talk because everybody's done this, right? So yeah, it looks like about little less than little more than 2/3 yes, but a fair number of no's, right? So good to see that that a lot of you have, and we'll try to fill in some blanks here. Air purification, right, or air filtration, whatever you want to call it, trying to find your solution could be really tricky. The marketplace is very crowded. I think we could all say in large part due to COVID pandemic, right? And there's a lot of stuff out there. And if you try to, search for indoor air quality, you're going to get way too many searches that are going to be helpful. And kind of navigating between information, guidance, regulations, and all of the commercial companies is very difficult. On top of that, and this is because in many ways the standards are new and evolving, there's just a lack of transparency on basic performance specifications. I'll show you a couple examples as we go through, but there's a number of specifications on how you measure how well a solution works, whether it's airflow, whether it's the quality of the filters that are used inside the machine, how the machine is built, how many air changes, all these things that are kind of listed in the bullets here. Is the machine big enough? How often do you need to do replacements? All of these are not clear in many cases and can be a big source of confusion. And then third, in addition to, so like number 2 is about, hey, the mechanisms are correct and they're clear, but may not be transparent or confusing. But number 3 is about the marketing language itself just being plain old wrong or misleading. And for example, the second bullet there talks about square feet versus cubic feet. If I have a solution that doesn't work very well, but I give you a square footage, it might sound that it works better than it does because a square foot number can be bigger without recognizing the need that your ceiling might be taller, for example. And so lots of confusion on filters, on coverage or airflow, lots of confusion on alternate technologies that have been introduced mostly since the pandemic. And then you have, marketing speak to try to, add more credibility that may not exist. Talking about the standards first, I have some examples of some standards here. The 2 on the left are they're related to asbestos abatement. And some of you have probably consulted in asbestos-related work where you need to contain the area. You need to get a machine in there that's going to capture all the asbestos fiber and keep any of that material that's being pulled from the walls and the ceilings from exiting the room. These standards talk about, hey, you need a negative air machine. We'll talk about that in a moment. The number and capacity is dependent on the size. And the Minnesota regulations right below talk about some more specifics around what's called air changes per hour and a negative pressure differential where you have that being recorded using a tool. On the right side, talking about infection control, I mentioned the ICRA 2.0 risk assessment earlier. ASHE talks about this risk assessment in these class 3, class 4 construction areas requiring a pressurized containment area when the work area is contained. So you imagine you're in the hospital and there's ceiling tiles being open and there's work being done. That area has to be contained to prevent the stuff you're pulling out from getting into neighboring rooms that may have patients, staff, or visitors, right? And then finally, in the lower right, talking about mold, again, containing the area under negative pressure. Mold is interesting. There's growth in regulations around mold at the state-by-state level. From 7 states in 2003, at least 12 the last time I checked. So it's definitely on the rise. So navigating these standards is tricky. Lots of changes, of course. On the marketing and the misleading language, this is still one of my favorite pieces of information, even though it's now almost 3 years old. This tweet from Dr. Zatari, where she lists a bunch of things that companies might be claiming are as good as the real thing. And we're going to talk about HEPA filters here in a moment. But this is a bulleted list of all of these things or claims or messaging in various products that are not what you might think they are. And in fact, just the other day, I went on Amazon and I picked one at random and I typed hyper HEPA into Amazon, and I got a product, and I found a bullet in that product where the company's talking about their hyper HEPA medical grade filtration technology stopping 99.5% of all particles. I'm going to show you in a moment what HEPA really is, and it's better than that, right? So I see this as this is a red flag to me, right? The claim kind of reads pretty good, right? If you read this, it's like, that sounds pretty strong, but it's not HEPA. And if your job requires HEPA, this is a red flag to watch out for example. So let's move on. I have another poll here to get a sense of your familiarity with this.
Great. So the next poll here is, have you had a recent project that required a HEPA filtration solution? Yes or no? Give it just a couple more seconds here. Okay. Oh.
We love the last minute answers, right?
Last minute answers.
In there.
Okay.
Wow, this is very interesting, right? So about 50% say yes, and about a third are no, and then the remaining, the remaining 16% on the maybe. So maybe half and half here, or a little more than half. Interesting. So hopefully some good information, some new information that will be helpful here. Let's talk about what proven methods do exist for improving indoor air quality. Well, step one is, you just get some outside air in, right? If you get some outside air in, you're going to improve your indoor air in many cases, not all cases, of course. You do that by, routing your HVAC, or you open windows, you send people outside, all those things that we were, encouraged to do during the pandemic. That's a problem, right? It doesn't always work. Here in the state of Washington, right? If there's heavy wildfire smoke, we're not going to open our windows, and kids aren't going to go outside at recess. They're going to have to stay inside. It might be too hot. It may be too cold, putting the wildfires aside. You try to run your HVAC at higher consumption, and you're going to pay higher energy bills. Those are all the trade-offs that makes integrating outdoor air not an obvious given, right? You can't always do it, or you won't always do it. Instead, or in addition to, well, let's just filter out all the bad stuff that's in the air. And you do that using a combination of these HEPA filters, which we'll talk about in some detail here coming up. You could also use additional filters that are called MERV filters that are rated below HEPA, but they're very cost effective. And then there's this concept of activated carbon filters, which capture other types of less so particles and more around odors and chemicals. The big issues here when you use filters is, are you moving the air through that? Are you getting enough air through the filters fast enough? How often do the filters need to be replaced? Are the filters good enough? Those are all the questions that will come up when you're choosing a solution. You can also apply some additional technology to, I call this altering or attacking particles. So these don't necessarily capture the particles, but they do something to the particles, most notably when you're dealing with organic particles. You can use ultraviolet germicidal irradiation, for example, to deactivate bacteria. And many of the same issues apply around, can you get the air to or through these mechanisms? But there are a lot of open questions around the safety, the use of these items, as well as are there side effects around creating ozone, for example. And so it's a lot of buyer considerations when you're thinking about using these alternate particles. HEPA filtration by far is, the first thing really to look at. Question often comes up is, okay, well, why don't, instead of bringing in additional solutions, let's just take care of it in the HVAC. We can open up the HVAC and add a bunch of filters. Conceptually, that makes a lot of sense. You put filters inside your HVAC system, you're going to slow down your airflow, right? And the better the filter is, the more you'll slow down the airflow. The machine, the fans inside your HVAC may stop working there. Or just as bad, you'll really increase your energy consumption. You also have to be very careful if you have too much blockage or filtration in your systems. You can damage your AC unit, you can damage your furnace. And I always think the way I look at this is that the filters that are inside your HVAC system, they're to protect the equipment, not the people. Right? It's, you look at your furnace filter, for example, it's to prevent stuff that, we drop into the ductwork to damage the actual furnace. So caution here, if you're trying to just handle inside the HVAC, there may be some cases where it works or it helps. But I want to move and talk about the concept of the portable air scrubber. So the portable air scrubber is very simple. It's a thing that goes in your space. Dirty air goes in and clean air comes out. None of these four photos actually show you one, but give you an idea of where you might place these. Those of you that have gone to the dentist recently probably have seen a small version of a portable air scrubber with the little hose that comes close to where the hygienist is working on your teeth, as an example. And then the picture on the right shows somebody getting set up to work inside a containment zone. The portable air scrubber would be on the inside or the other side of that containment zone. The way that you can configure this portable air scrubber inside a containment zone is you would configure it as what's called a negative air machine. And negative air machines have been around a while, and many of you have used them probably around protecting the areas outside the containment zone from getting any of the particles that you are removing inside the containment zone. So for example, if you're pulling out mold or asbestos or lead, or for example, if you have a patient that you're isolating, contagious patient, you're going to contain that area with rigid or tarp or something. You're going to put one of these machines inside the room. It's going to capture the air, it's going to filter the air, and then it's going to send the treated air outside. And if you have the space contained, this will actually create a negative pressure differential in the room so that the natural physics is sending air from outside through any leaks or gaps, the outside the space in versus the contaminated air pushing itself out. And in fact, if you're doing abatement in many states, you have to record that differential pressure using what's called a differential pressure recorder or a manometer to basically prove that you're maintaining that differential in the room, that small pressure differential, so that the material is not escaping. These portable air scrubbers kind of conceptually are quite simple. We have the dirty air outside coming from the left. It's going to go through first what's called a pre-filter. These pre-filters look like your furnace filters, right? They're relatively thin, 1 or 2 inches. They may have cardboard frame, or they might just be a pad. They're typically MERV rated, which is a lower level of rating, but still relatively effective. It captures the big stuff. And then you have your HEPA filter next. Your HEPA filter, if you look on the picture, you kind of see this bold line at the right side of the filter. What I'm trying to show in this picture here is that nothing gets to the right side of the machine without going through that HEPA. And you got to be careful on buying maybe more of a consumer device where that seal may not exist. And in that case, dirty air will just bypass the HEPA, and that's not very helpful. So in this case, the air is flowing through the HEPA. It hits the blower and then gets shot out the right side through an exhaust, usually like an exhaust ring or an exhaust duct. And that's where your treated air is. And this system has to work, right? The size of the HEPA, the capacity of the HEPA, the size of the motor, the size of the blower, all of that has to be sized to all work within each other to give you the performance that you need. And, the performance that you need, of course, will be based on how much air you want to move through that machine and how quickly you want to move that air through that machine. And we'll talk about that a little bit more in a moment as well. Okay, let's do a deep dive and talk about HEPA filters. There's a lot of questions on HEPA filters. What do they mean? Why do I need them? And as I mentioned earlier, all these, I call them fake HEPAs. All these claims around, hey, I have this other thing that I want to call a HEPA, but I really can't. HEPA stands for high efficiency particulate air filter. It's not new technology. It's been around, since the 1950s. And there are 2 key specs on HEPA filters. They either are specified at 99.97% or 99.99%. And what that spec means is that at a particle size of 0.3 micrometers or microns, I'm going to capture either 99.97% of those particles or 99.99% of those, depending on what HEPA I have. The reason 0.3 is the metric here is because it's kind of at the sweet spot of where the HEPA has the lowest performance. The HEPA will capture bigger particles much better than that because bigger particles can't get through the filtration material. Intuitively, that probably makes sense. But it actually also captures more efficiently smaller particles because those smaller particles are so small and so light that they're subject to this physics phenomena called Brownian motion, and they can't get through the HEPA without being kind of steered toward the filtration media and getting stuck. And so that's why the spec is around 0.3, which is that kind of sweet spot at the worst case performance. So these HEPAs are very, very effective. The pictures that I'm showing you here are a couple industrial HEPAs. The one on the left is a 12-inch by 12-inch by 12-inch size HEPA. The air is flowing from kind of the back of the screen out to the front here, and you could see the black gasketing, which is used to provide a strong seal there. This is this particular HEPA, as I said, 12-inch by 12-inch by 12-inch. If I were to disassemble the filter and measure the amount of filtration media, it would be about 56 square feet. Okay, you might run into a situation where you're looking at a filter or you're looking at a machine online and they're advertising, hey, I have this machine and it has 4x the capacity because it's 4 square feet instead of 1 square foot. But if you look at the filter on the right, it is 4 square feet from the, like if I look at it from the front, it's 24 inches by 24 inches, but it's only 6 inches deep. It's a thinner HEPA. And so if you do the math, it's only 112 square feet, which is twice the capacity, but it might be marketed at 4 times the capacity. And so something to watch for. Many machines, like if I went and looked at negative air machines that I could buy today or portable air scrubber, I can buy machines at 12-inch deep filters, 6-inch deep filters, and some that are even less than that, say 2-inch deep filters. And many of our machines will support the 12-inch and the 6-inch, so you have your choice. So we're talking about the word capacity here, right? And the capacity really defines how much filter material you have inside the HEPA. The way these things are built is you take a long single built, it's not really a panel, it's just a continuous panel of filtration material. And if you look at the picture on the right, you can see that's being fed through the top of that machine. And it just gets folded back and forth over on itself with these separators in between. These separators are, as I showed in the previous picture, you can kind of see they're little metal separators. And the purpose of those is just to make sure that 100% of that filter media is accessible by the air that's moving through the machine. And so in the diagram on the right, the air is moving from left to right, or it could move right to left. And it's gonna, the air is gonna hit the media either at either end or as it travels down in any of those channels and get caught by the filter as it's working its way through. And so kind of conceptually, they're not that hard to build. You kind of fold the media back over and over and over, as you can kind of see what's being done here as a picture on the right. The concept of capacity is how much media you have in the filter. And so here's an example of 2 24 by 24 by 12 HEPA filters. The leftmost one is advertised as standard capacity. If I were to disassemble that and measure how much media is in there, it's 224 square feet. Or I could buy a high capacity HEPA, same size, but if I disassemble it, I measure the media to be 298 square feet. And if we wanted to do the experiment, we could zoom the picture in and we can count how many pleats there are or how many back and forths there are. And we can do the math to see that in this case, there's close to 30% more in this case. A high capacity HEPA filter will let you move more air through it because it has more places for air to go. And it will also last longer because it has more filter media. And so that's a conscious choice that you would make when you're choosing what kind of filtration solution for your project. So moving on, now that we've established, that we want to use a air scrubber or a portal or a negative air machine with HEPA filtration, we now need to decide how much do we need, or how big do we need, or how fast do we need? And so the definition of air changes per hour is commonly used. And for example, you see here in the OSHA regulation around asbestos abatement. If you're doing containment and you're pulling asbestos, you need to change 100% of the air in that containment space 4 times an hour, which means your machine or machines need to be strong enough to get 100% of the air volume through the machine every 15 minutes. Okay, so 4 air changes per hour is an air change every 15 minutes. So then we need to know, well, what does our airflow need to be? And that measurement is what's called CFM, or cubic feet per minute. And so let me bounce into that a little bit. Cubic feet per minute is the volume of air that's moved through the negative air machine or the portable air scrubber. And we'll come back to this with an example here in a moment. There's also a definition called the CADR, or the clean air delivery rate. And so I want to distinguish these two. CFM just says how much air is moved. CADR tells you how much air is moved that's been treated. And in an ideal world, those two numbers are the same. If I'm going to move, 10,000 cubic feet of air through the machine, I want 10,000 cubic feet of air to be treated, right? That's what I want. And so if your machine is not fully optimized and there's places for the air to escape or bypass, your CADR will be lower. If your HEPA is not 100% efficient, your CADR will be lower. And so we already have established that your HEPA is not 100%, but it's, say, 99.97%. And so in a machine that has full, like a perfectly well-designed machine with a 99.97% HEPA, you're going to get a CADR rate equal to 99.97% of the CFM, is how that works. I'm going to show you an example, but before I do that, I do want to mention that CADR is a publicized specification that's been adopted by the Association of Home Appliance Manufacturers on this program that they call the AHAM Verified. And there's a number, you'll see this label on the right here. You'll see this label show up on mostly consumer machines. Like if you go to, Target and you want to buy a machine, you might see this label on there. And you're seeing 3 different numbers for smoke, dust, and pollen that are tested in a particular space and given a rating, a CADR rating, along with what your size recommendation is for how this machine can be used. There's a couple problems here that I wanted to point out here. Well, number one, this dimension here of 450 is mentioned in square feet. So if you try to put this in a building that has a taller ceiling, you're going to get less. It's not going to work as well. Okay, but the bigger issue here is that this certification process, the machines are tested in a chamber that's about 1,000 cubic feet. And industrial and commercial air purifiers that are running at 500 CFM or more, they're just too big for this test. They simply cannot be used in this test, and that's why the industrial machines haven't adopted this standard. And so if you see some standard like this, it's probably not for the projects that you're working on. Okay, let's go through an example, because I talked about these different metrics, but I haven't tied them all together here. So we're going to take an example of a fairly large space. We got 50 feet across, 50 feet across and 50 feet wide, and we have a 12-foot ceiling in this case. Okay, that's the area that we need to treat, either with a contained space with negative air or just an open space like a call center, for example, or a patient waiting room. And we're going to multiply those 3 sizes together, 50 by 50 by 12, and that gives you a volume that needs to be treated of 30,000 cubic feet. If I want to follow that previous regulation that says I want 4 air changes per hour, you do the math here. You take your 30,000 cubic feet, I multiply it by 4, and that gives me how much air I need to handle in an hour. And then I divide that by 60, and that tells me how much air I need to handle in a minute. And so 30,000 times 4 divided by 60 is 2,000 cubic feet per minute. So you're going to look for a machine that has a specification of 2,000 CFM or better. Of course, you can use 2 machines at 1,000 each, and they just add up together if you want it as well. And so the math to kind of convert between these two is relatively straightforward. And if you wanted 6 air changes per hour instead of 4, you would just change your equation accordingly. When you're out shopping for a machine, that machine is going to give you a CFM specification. And this is a little bit of detail that you probably won't find in the specifications for the machine, but I think it's worth kind of diving into some of these details to talk about what are the different things that affect how that machine is designed and how that machine is working. The most important items here, as I mentioned earlier, is your HEPA filter, your size and capacity of the HEPA filter, and then the motor that's paired up with that inside the machine. And so you have a motor in the machine, and when you place a HEPA inside that machine along with other things, that machine is now subject to what's called a pressure drop. And what the pressure drop is it's simply the difference of pressure inside the machine versus outside the machine. And the reason why you have a different pressure is because the air is being pulled or pushed by the motor through the HEPA. And so the motor will be maybe pushing more air into the chamber while it's working its way through the HEPA, or it's pulling and it's quote unquote waiting for air to get through the HEPA. And so this chart here is showing what's called a fan curve for the machine. And the green line is showing here that you have a pressure drop value, that's the y-axis, a pressure drop value that's maintaining a fairly constant rate until it starts to really drop off. And you can see the green line stays relatively flat, and then it starts to fall off. It's hard to see, but it starts to fall off around 1700. But you can get it maybe close to 1800 before it really drops off. And so this is an example of a fan curve that might give you a machine that's specified at 1800 CFM. One thing to note here, as that HEPA filter fills up, it gets more efficient, right? It gets better at capturing things. And you'll see this, for example, in your refrigerator at home. You have a water filter, like if you have a refrigerator with a water dispenser, and you notice over time the water dispenser is running slower and slower, it's because the filter is getting better and better. And at some point, it's so irritating that you'll replace the filter and put in a new filter, right? The HEPA filters work the same way. The HEPA gets better and better and better. At some point, the pressure is so high on the HEPA, the motor is working hard, but not less air is getting through. And many machines will tell you, they'll have a light, for example, that will say, hey, it's time to replace your filter. But if you're not getting the airflow you need to maintain that negative pressure differential, you'll have to replace your HEPA. There's also one final note here that there's other factors that affect the performance of your machine as well. If you have ducting that's moving, lots of ducting with turns and kinks will reduce your airflow. Then there might be other things in the way that may reduce your airflow. So this is not a cut and dry, do the math and you're good to go. So other considerations that you have to take into account. So I want to talk a little bit about CFM, and I've kind of alluded to earlier in the presentation that, there's a CFM spec and there's potentially a lack of transparency on the spec. In fact, there are units out there that claim a certain amount of CFM, and when you measure them, you do not get that CFM. And if you think about other specifications out there, like if you're shopping for a performance car and you want to look at that 0 to 60 mile, how quickly do you go from 0 to 60? You can dive into the details to understand how that number is measured. And you can replicate the test on your own if you want. That information is very, very sparse in this industry. And you have companies that are speccing their CFM maybe on a machine before they've put the pre-filter in there, or maybe without some other, configuration. Or worst case, they're basing it based on the math only on the motor. There's a lot of reasons why that CFM, like you buy the system and you will not get that measurement that's spec'd. The way that we do this, and we call this our true CFM measurement, is we take this methodology that's was defined by AMCA back in 2020, and we measure the airflow. And if you look on the picture on the right, you can see there's this device that's going into the ducting. This is an airflow meter, a hot wire airflow meter. And we're measuring at 2.5 times the diameter of the duct. And so we have this 30 inches out where we're measuring the CFM from the machine. And the reason that I have to go this far out, and I can't just measure it right at the exit or further out, is because if you look at this picture on the left, that 2.5 times, which is called the effective duct length here, gets you even measurement. And it'd be a fun video for me to show you, but I could show you a different measurement of where I have one of those little miniature fan-based airflow meters. And if I move it around the exhaust of the machine, I can get different measurements. And you can imagine me moving that around until I find the highest measurement and claiming that's my CFM. Probably not the best way to make a specification. And so what this does is gives you uniform measurement. And our true CFM specification is, hey, this is how we measure, and this is how you replicate. And so something else for you to watch out for. In fact, let me conclude here with some of these buyer considerations here. I just talked about the CFM spec. You're working in high stakes environments. Your employers have high expectations. Your clients have high expectations. Quality matters. Quality is first and super important. Watch out for those false or missing HEPA claims or other specifications for that matter. Another really important thing, especially in community spaces and office spaces, is people care about size, noise, and cost. This was I think in 2021, I believe, when I went to see an eye doctor, and I'm doing the exam, and we're both masked up, and he points to this little device on his desk, and it's like, look at my air filter. It's so quiet. And I had to I don't remember if I called him on it or not, but I know I was at least thinking, well, it's so quiet because it doesn't do anything. And so our machines are loud. Some of them are louder than others, and our competitor machines, some of them are loud. But if you're looking for a product and the product is being marketed on size, noise, and cost, it may mean it's not doing what it needs to do. You want to look at your total cost of maintenance, especially if you're deploying fleets of these machines. You can get smaller HEPAs, 6-inch deep HEPAs instead of 12-inch deep HEPAs, but you got to replace them twice as often. And that means people have to go with tools, and you got to move HEPAs around. Got to look at that total cost of maintenance. These larger machines, like I mentioned, they are noisier, but you can place them away from people. You can place them in the corner of room. You can change the speeds, if you have sensitive, if there's a point where the noise makes a difference. I will mention, and it's in parentheses because, this is not, of course, the main reason, but occupants do adapt, right? We're humans, we're good at adapting. For example, we've been running machines in our office space since 2020. And when the machine is off, I notice it, right? And we have our phone calls, we do our Zooms. There's a machine running, here with me right now. And occupants do adapt. So I think with that, we'll see what other comments or questions we have, Jessica, and we can take some time here if we have any.
Yeah, great. So we have a couple questions that have come in, but if anyone wants to send in anything they've been thinking on throughout the presentation, now is a great time for you to put them into the chat box. And as always, if you remember something following the presentation, please follow up with us directly. We'd be happy to get back to you with those answers. But one of the questions that came in is, can you use these machines to cover chemicals and odors?
Yeah, that's a good question. I don't really cover that in the material. There's a mention of it earlier, but there's a type of filter called a carbon activated filter. And carbon activated filters are really effective at capturing odors and volatile organic chemicals, or VOCs. And in most of our machines, or all of our machines, I think you could add carbon filtration to the existing solution And in some cases, you can replace the HEPA filter and or other filters with carbon filters. So it depends on your application, of course, but carbon filtration works really well for those problems.
Great. Another question is, how long do HEPA filters last, and when should I replace them?
Yeah, so that's also, I mentioned the cost of ownership. We have found that when machines are running 24/7 in relatively dirty areas, say in our manufacturing shop floor, that you'll need to replace that HEPA about every 12 to 16 months. In cleaner environments that might not have carpets and have people, maybe you can get, 16 to 20 months. So 12 to 16 months.
Okay. And then is the effective duct length always 2.5 times the exhaust diameter?
Okay, so that's related to that picture that I was showing earlier, and I think I can go back, right? Yeah, so yeah, this is the math, right? The math says here that based on the diameter of the duct, in this example, this machine has a 12-inch duct diameter. It's covered by the metal duct, so you can't really see it, right? But like our products, we have 8, 10, and 12-inch ducts. So in whatever those duct sizes is, you would do the math. I think I'm answering the question.
Yeah, sounds good. I think that's it, unless there's any other questions that we get in the next couple of seconds here. But as I said, if you have any questions that come to mind later, send them over to us. We'd be happy to follow up with you. As I said, this presentation is recorded. It'll be available for you as well. Okay, one more question. If considering using one of these machines, how do they get in touch with us?
That's a great question. So the simplest way is to go to omnicleanair.com, and that's all one word, omnicleanair.com. And I think when we send out the slides, you'll see my email at the front, and you just the same thing, right? You go to omnicleanair.com. You can see all of our content, and from there, you have the option to go through your distributors that you may use, or a distributor that you favored, or from our direct shop site, to make your final decision.
Yes.
And I don't think we have an office phone number in the material, but I'll just give that right now. It's 866-863-0417.
Great. Another question is UV light in a HEPA machine needed or effective for removing infectious agents from the air?
Good. That's a good question. I think that we would say it's not needed. It's an additional risk mitigation. And if you think about it, that HEPA is already capturing 99.97% or 99.99%. So if you're running that machine fast enough, 3, 4, 6 air changes, most of that, the infectious particles are going to get caught by that HEPA filter. That being said, if you have UV light in there, it is going to be very effective at disabling those particles. So any that do escape will be disabled. It's an additional mitigation. There is one more thing that's useful about UVGI. If I have UVGI in my machine, it is constantly shining on the underside of that HEPA. So when you pull that HEPA out, it's way more safe than just pulling the HEPA out, when there might have a bunch of bacteria on the underside of the HEPA. This choice of UV will be yours, and it will be mostly based on how quickly you're changing the air in the space would be my answer there.
Great. Another question is, do we include noise info on our product literature?
We do, yeah. So the noise specification in decibels is the standard we use is the NIOSH 6-foot spec. So that will be the noise at 6 feet away from the machine running on its highest setting.
Great. And I think that's it for right now. So
a lot of stuff.
Yeah. Thank you everyone for joining us. We really appreciate it. As we mentioned a couple of times, you'll be receiving the recorded version in your inbox here shortly. And if you have additional questions, don't hesitate to let us know. Thanks again for joining us.
Thank you.